Hello friends, this is Durga again and I'm from ITversity. As part of performance tuning, I'm talking about loading data effectively into the database. So I'm trying to showcase what are the typical wait events that might pop up when you try to load data in parallel and what are the solutions for that. So far I have covered how we can play with commit rate and get a good degree of parallelism. And now I will be focusing on Initrans. I have covered the concept of Initrans as part of the last video itself. In this video, I will try to just demonstrate how we can tweak the Initrans, and then we will rerun the scripts in parallel and see how it will perform. So I'm going to my SQL developer. I'm truncating this table called stock underscore EOD. Remember, if you already have the data and if you want to increase the Initrans, you not only issue the alter command, you also have to rebuild the table. Otherwise, the Initrans will not be in effect for the existing blocks until transactions happen on those blocks for the first time. What I'm trying to say is, as of now, the Initrans on stock underscore EOD is 1, and each and every block will have only one transaction, one slot for each transaction in the header. When you try to do transactions like insert, update, or delete on the data set, even if you change the Initrans to 2 or more, still the existing blocks will have only one slot in the block header. If you want to have it in effect immediately, you have to rebuild the table, and data has to move from the existing blocks into the new blocks, and those blocks have to be formatted with higher Initrans value. Okay, so for the first time when you try to increase the Initrans on a large table, it's not a single step process, it's a two-step process. First you need to increase the Initrans for all the tables and the indexes that are created on the table, and also you have to rebuild all of them, which means it requires downtime. So you have to be extremely careful when you are trying to increase the Initrans for the first time. But even if you do not increase the Initrans, probably to get the desired degree of parallelism, it might take time. As soon as the blocks are read into the memory for a transaction, automatically the slots will be increased while writing back onto the database files. But for the first time, it will be only one, and you might still see the wait events even after increasing the Initrans. Now, to avoid that, to avoid the rebuild of the table and all those things, I am just truncating the table, and then I am actually altering the table stock underscore EOD Initrans. In this case, I want to give 6 because I am using 6 threads. I am giving it to 6. If you give very high Initrans, there could be empty slots which can waste some of your storage. So you have to be careful before increasing the Initrans blindly. The ideal situation will be to get a correct Initrans value and the appropriate commit rate. So commit rate and the Initrans are related. So if you are using 6 threads in parallel, and if you are using commit rate as 1000, probably 3 Initrans might be good enough. If you are using 100,000 as a commit rate, then you might have to have 4 or 6 for the Initrans on the table as well as the index. So you should be very careful and understand the effect and the dependency between the Initrans and the commit rate, using which you are trying to load the data in parallel. In this case, I am just using 6 for the table. Let me get the syntax. Okay, it's Initrans, not ini underscore trans. So now the table is altered. You can actually look the value in the DBA tables. Now ini underscore trans becomes 6. Similarly, we have to get the index name and alter the index also. Alter index Initrans 6. Okay, now both of them are altered, and now let me run the scripts in parallel. So if you are actually changing the Initrans on the tables that already have the data, then you have to rebuild the table, and also you have to rebuild the index. You can go to the Oracle documentation and get the syntax to rebuild the indexes. Rebuilding indexes is pretty straightforward, but when it comes to table, you have to be a little bit careful, because if the table is too big, it might need a very long downtime on the table. That being said, let me run this scripts 2010, 11, 12, 13, 14, okay, I made a mistake. Let me kill all these things. So I have killed all of them, and let me truncate the table again. Okay, so now let me modify these scripts with commit rate to 100,000. And hit enter, and now let me run the no hop. And now the scripts will be running in parallel, and now we will see whether that wait event is there after changing the commit rate to 100,000 with Initrans of 6 on both table and index. So you can ignore this first spike because we killed in the middle, and also you can actually run select count of 1 from stock underscore UID to see how much data is loaded. Already 1.305 million records are loaded into the table, and it's going at decent pace. Okay, now you can actually click on this insert URL, but the problem is it's actually showing the previous one also. That's why you are seeing too many wait events. Still you can see this NQTX contention, but the impact of that will be very low in this case compared to earlier. Again, buffer busy waits and all those things is it is trying to write too much of data that server can handle at this time. But we are trying to primarily focus on NQTX contention, which is the main thing that can cause issue in loading data using parallel approach. And irrespective you run manual parallelism or Oracle supported parallelism using parallel hint, this issue will occur, and the solution is either by increasing the commit rate or by managing the commit rate to more manageable value, or by increasing the Initrans. So now let us see how much data is loaded. It's almost done now. 2.9 million records are already loaded, and already one script is completed. So most likely it have completed. There is only one more script. And the script is, all the scripts are completed. And you can see that by increasing the Initrans, still having 100,000 as our commit rate, the performance is much better compared to our first run, where the Initrans is 1 for table and 2 for index, and 100,000 as the commit rate. So I cannot tell exactly how long it took as part of the run previous time and how long it took this time. But if you want, you can actually set the timing on or set the timing on as part of your scripts, and you can track those things. But the bottom line is, by using appropriate Initrans values on table and index, as well as by having the manageable commit rate, you can resolve this very important wait event, which is called NQ transaction contention, which will actually serialize the load process, even though you have multiple threads trying to load the data into the database. That being said, that's it about parallel loading and the very important wait event called NQTX contention. The reason why we are still seeing it is for index 6 might not be good enough. We might have to increase a little bit more than 6. Anyway, that's fine even if there is a little bit of wait event, but you need to understand the magnitude of its the magnitude of the issue that is being caused by this wait event, more than whether it is going away completely or not. In this case, it is much higher compared to our last two runs by changing commit rate, as well as increasing the Initrans on table and indexes on the table. I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you want to provide feedback or ask any technical question, or even identify any mistakes as part of the content, please let me know. I will be glad to accept the feedback. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye. Actually, before closing, you can see that this one is a little bit leaner compared to this run. I hope it is obvious to you, but I strongly feel that it is leaner. The reason is we have used lesser higher commit rate with higher Initrans values compared to lesser commit rate and lesser Initrans here. So definitely there will be some difference in the performance. Unless you are trying to load huge amounts of data, and the issue might not be that obvious. You can actually look into AWR reports to understand this in detail. That being said, thank you. Bye.